Okay, so we just completed the design for the single phase grid tied converter for solar system, for solar energy system. Uh, Next, we'll be going through a brief discussion about wind power generation. This will be our last topic for today's session. In case you have any doubts, then please feel free to ask. Okay. So next we look up about the power quality improvement in wind energy conversion systems. So as I mentioned that this is the second largest renewable energy source for generating electricity in the world after solar energy. So when it comes to wind energy, in wind energy we are converting the kinetic energy of wind into electrical energy, and increased size because of the increased size and higher productivity, we have enabled the wind generation to become increasingly competitive alternative to the traditional power generation methods. The only problem with wind generation is uncertainty, that sometimes wind will be there, sometimes it will not be there. So if you look at the diagram of wind power generation, here what happens is this is called the hub. On the hub these blades are mounted, and when these blades rotate they have a gearbox inside, and this gearbox is connected to the generator, and the electricity generated by this generator is connected to the power converter, and the output of this power converter is given to a transformer. Then a system protector is connected in order to take care of the lightning or any other power surge problems, and then it is connected to the grid. Also, a part of this power is given to the local some monitoring units which might be present there, or you could have a battery storage connected to this power generated. So this is a very generic system. You could have multiple configurations, but the overall structure will almost remain the same. In some systems you won't need the power electronic converter. In sometimes systems you won't need the gearbox. A lot of hidden different combinations are possible, but the overall system will remain something like this. So when you look at the advantages of wind power is a cost effective and cheaper solution than solar, and it creates job. It's a clean fuel of source. It is sustainable in nature. So there are two options for making this wind farm. So you could either make it as onshore and offshore. So what is onshore and offshore? So whenever you have a land, if you go to a beach, this is your beach sand and this is your side of the water. So when you go towards the water, it is called offshore. And when you go towards the land, it is called onshore. So what happens is we are able to install the wind systems offshore also, but the challenges there is that we'll need a very high pole in order to install it there, and it will be a rigid structure, and so the cost will be higher. And the problem with onshore installations is that we have very limited sites, right? We have very limited onshores, and most of them have saturated. That is the challenge that we face in wind power generation. Then, if you look at another challenges, wind power must still compete with conventional, so we have to make it cost effective. Then we have to give a lot of real estate to this project. Then, due to the presence of turbines in these wind generation systems, a lot of noise and aesthetic pollution occurs. Wind plants also impact the wildlife. There is always an intermittency issue, right? Wind sometimes blows and sometimes it does not blows. And offshore towers, that means that towers that are present on the water are much more expensive than the onshore towers. And onshore sites have already saturated. So these are few of the challenges that are faced. So if you look at some of the statistics of the wind power sector, overall the world capacity for wind power is 650 gigawatts. Total installed wind capacity in Asia itself is 290 gigawatts, which is 44% of the global capacity, which is very high. And India has, as of 31st October 2020, India has installed 38 gigawatts already, and India is the fourth highest capacity of wind installed in overall world. And if you look at the state-wise distribution, you can see that overall this is the potential. This is not the installed. This is the potential. So Gujarat has the highest wind potential. Rajasthan, Maharashtra, Tamil Nadu, Madhya Pradesh, Karnataka, Andhra Pradesh, and Kerala. This is the decreasing order of wind power potential that is present in these states. Then there are a lot of companies who manufacture these overall systems and turbines for these wind power generation systems. Zephyros, GE, Siemens, Vestas, Renewable Power Energy, Multibrid, Enercon. And these are few of the examples of the wind power plants which are already present in India. The biggest one in India is present in Tamil Nadu, which has a capacity of 1500 megawatt. And the second largest one is in Rajasthan, Jaisalmer, which is 1000 megawatt. And the third biggest is in Maharashtra, Dhule, which is 528 megawatts. So again, in this system, we know that we have a wind energy conversion system which we need to connect to the grid. This is a single line diagram. Then a lot of challenges are present. These are highly variable wind power is generated. There is the number of wind energy plants are increasing in nature, and there are a lot of power. As a result of that, there are a lot of power quality issues that are present. When now when you look at the categorization of wind energy conversion systems, there are only two types of wind energy conversion systems majorly. One is fixed speed type wind energy conversion system, another is variable speed type. So what does fixed speed type means? So here in this system, the generator will be rotating at a fixed speed irrespective of the input wind energy that is being given to the system. So no matter at whatever speed this wind turbine rotates, the speed of this induction generator will remain constant. This is called a fixed speed wind energy conversion system. Whereas in a variable speed conversion system, we change the system. We put these electronic converters using which the speed at which our system rotates is different in order to operate at the maximum power condition. So, since variable speed conversion systems include these electronic converters, it becomes much more expensive compared to the fixed speed wind energy conversion systems. But because of the increase in efficiency nowadays, most of the 75% of the companies manufacture variable speed wind energy conversion systems, and that is why they are very popular because of the increased efficiency. So in these variable speed wind energy conversion systems, you could use either an induction machine or a synchronous generator or a doubly fed induction machine. So doubly fed induction machine is the most popular ones that is used in most of the companies, and sir has explained in his lectures of the control scheme and the control equations for most of these topologies, so you can go through the explanations. So this is the diagram of, let us say, squirrel cage induction generator, and then there is this control algorithms present. So sir has given the details of all the possible topologies. Most of the possible topologies he has covered in his lecture, so you can go through them. Again, don't let these diagrams overwhelm you. Look at the bigger picture. There is this wind turbine, gearbox, induction generator. Now you have a grid to connect. So from this generator you will take power. There will be rotor side converter, then there will be grid side converter, and this will connect to the grid. So there will be some loads connected here, some loads will be connected to the grid later on, then there will be a ripple filter here. Okay, so this is again a simple system if you try to break it down into parts, and once you understand the big picture, it will be easy for you to understand these control algorithms one by one. Okay, so you can take your time and go through these algorithms, and we can just look at one example problem if you want. So if you say that there is a 2 megawatt wind turbine for doubly fed induction generator based on wind energy conversion system, assuming that the rated wind speed is 12 meter per second and the optimum tip speed ratio is 7.2, the maximum coefficient of power is 0.44, and the air density is 1.224 kilogram per meter cube, and we have to assume a minimum slip of minus 0.3, up to which the DFIG is operated at the maximum power point. So this looks like a complicated problem, but the only thing we need to remember is this power expression. So this is the wind turbine power expression. So if you look at this expression, there is R, which is the radius of the wind turbine, VW is the wind velocity, and Cp is the coefficient of the wind turbine. So if you just put the values in this expression, we already have the power for the wind turbine. Using that you can find the radius, and once you have the slip uh, and you know the operating speed of the wind turbine, you can find out the rated speed of the turbine. Using that, this is the formula for the tip speed ratio. Using that you can find another coefficient for the wind turbine. So this is how you can simply, these equations, if you look at the detailed derivation of the wind turbine system, you can obtain these standard equations, and once you know these equations, you can easily attempt any kind of problems that are related to these kind of systems. The overall thing that you need to understand is how this overall system at the bigger picture. So in this bigger picture, what is happening is only this generator and power converter part is varying in nature. Otherwise, overall this system will always remain the same. Okay. So you just have to look at the mechanical equations of the standard wind turbine system, the power equation of the turbine, and few coefficients that are defined in the system. So you can do the designs on your own, and the overall picture will be clear once you look at the bigger picture of the system, similar to the thing that we discussed in the solar wind generation systems. So this is where I'll end my discussion for the course content. If you have any doubts, then you are free to, the floor is open. You can unmute yourself and ask any questions if you want to. Okay, in case you don't have any problems, then I'll end today's session, and I am dropping my email ID in the chat box. If you have any doubts, you can write to me at this email ID, because this is my last session and I want to be accessible to you guys after this session. So you can write me in mail if you have any doubts that you need to be that you need clarified. And Asif sir, I don't know what is the maximum marks. I think you can find it in the guidelines that are given to you. But whatever is the maximum marks, most of the questions will be covered from your assignment problems. And in order to make yourself, comfortable with the problems and the speed and everything, you can solve the problems that are present solved by Bhim Singh sir in his lectures. So that is the best suggestion I can give to you. So it doesn't matter whatever is the thing. I think the exam is maximum 1 to 1.5 hours. It's not more than that. So the questions will be simple. The level will be similar to your assignment level. It will not be more than that. Okay, so you can just solve your assignments and just do a proper revision of all the topics. And for problem solving, the main part of this course will definitely be problems, numerical problems. Okay, so you need to focus on that. And once you so try to do understand theory with numericals, so that you will be able to solve any kind of numerical, even if you might not have solved it before. So try to understand the theory behind it by using numerical problems. That is what I would recommend. And once you do that, I think you will be able to do good in your test, whatever is the number of marks, whatever is the number of question, whatever is the type of question, you all will be able to do good. Okay. If you have come this far and solved all the assignments, I think you can confidently sit in the exam. And just in order to do your best, just do proper revision, because we have covered a lot of topics. Okay. So just don't forget to revise. And along with the theory, go for revision of numerical problems as well. That is what I would recommend. Okay, okay. So in case you all have access to my YouTube channel, in case you have any doubts, you can just let me know on my email ID, and I'll keep on posting the content related to power electronics. So I'm a power electronics person. I'll always keep on posting content related to that. So if you are interested in that, you can just keep looking up to my channel for more content. And if you have any other special requests that you need related to power electronics, you can write in the comments. Okay, guys, then if you don't have any other doubts, then I'll end today's session. Okay, guys, then all the very best to you, all of you, for your test. I hope you do great, and just do proper revision and with confidence attempt the test. Don't be nervous. Half of the journey is, completed once you are not nervous and attempt the test confidently. Don't be scared. Nothing is going to go wrong. Okay, you all have whatever you do in your life there. It's just be calm, give your best. That's it. Okay. And if you have any doubts, you can always write to me. I'll try to do my best and solve any doubts you have. Okay, guys, then have a good night. I'll end this session today. It was nice teaching you.